Good evening. Is it audible, my voice? Is it audible? Okay, good. So it is a starting session. So welcome to ACE Engineering Academy, all the participants. My name is J. Nageswarao. I'm going to teach the control system subject. Control systems. The weightage is for gate is 10 marks. For IES 100 marks. Prelims and mains more than 100 marks they asked last year. The syllabus is same for gate and IES. So the syllabus, first I'll write the syllabus. The structure, first one is transfer function, block diagrams, signal flow graphs. The second one is time domain analysis. In time domain analysis, again, two types of analysis is there. One is transient analysis. The second one is steady state analysis. The next one is stability. S means stability. Again, in the stability, two types of analysis are there. One is time domain technique. Time domain technique. The second one, frequency domain technique. Frequency domain technique. In time domain technique, again, RH criteria, and root locus. In frequency domain technique, Bordeaux plots and Nyquist plots. Next, compensators and controllers. Compensators and controllers. The next one is state space analysis. State space analysis. So this is the complete structure of control systems. So main textbooks what we have to read. The textbooks are, first one is control system engineering. Control system engineering. By NICE, NISE. The second one, same title. Same title. But author is Nagrath and Gopal. The third one is automatic control systems by Bishiko. Fourth one is control systems. Control systems. Principle and design. Principle and design by M. Gopal. The fifth one is modern control systems by Ogata. These are the 5 standard books for control systems. You can purchase the first or second book as you wish, either NICE or Nagrath and Gopal. Who are preparing for GATE, they can purchase the NICE textbook. Who are preparing for IES also want it, you can go for Nagrath and Gopal. So first I'll give the introduction about each and every topic. So what is a transfer function? Basic idea about each and every topic. Then I'll start the subject. So get the screenshot this, all of you. Get the screenshot. Next. First of all, basically, what is the main objective of control system? What is the objective of control system? What is the main objective of control system? To get the desired output, mainly. To get the desired output or accurate output. To get the desired or accurate output. To get the desired or accurate output. Why we don't get the desired output? What is the problem? What is the problems in the system? Why we don't get the desired output means main problem is high frequency noise signal. High frequency noise signal. The high frequency noise is affect the system performance. Mainly this high frequency noise. High frequency noises affect the system performance very badly. That's why we require to eliminate the high frequency noise signal. We require to eliminate high frequency noise signal. How can we eliminate high frequency noise signal? By using low pass filter. By using low pass filter. By using low pass filter. Low pass filter. So that's why control systems are basically designed as a low pass filter. Control systems are basically designed as a low pass filter. Because unless until you eliminate the high frequency noise signal, we don't get the desired output. That's why even if you see the system transfer function, for example, if you see the system, what is the standard form of system, mathematical model of the system? K into 1 plus S tau 1, 1 plus S tau 2, and so on, divided by S power n into 1 plus S tau A into 1 plus S tau B, and so on. This is a mathematical model of the system. So here, why they put it here? N poles at origin, 1 by S power n. What it indicates? Actually, what it indicates? It indicates the n integrators. 1 by S is called integrator. N integrators. Integrators are what? Low pass filter. That means n low pass filters. So the mathematical standard form of the system includes the n low pass filters. Why low pass filter? Mean to get the desired and accurate output, to eliminate the high frequency noise signal. Basically, be remember, control systems are basically low pass filters. Control systems are basically low pass filter. That you be remember. Okay. So that's why they've taken 1 by S power n. 1 by S is called integrator. So n low pass filters includes in the control systems. Even they told the poles are greater than zeros, then the transfer function is called strictly proper transfer function. Strictly proper transfer function. If poles equal to 0, then it is called proper transfer function. If the poles are less than zeros, then it is called the improper transfer function. Then it is called improper transfer function. So be remember, always the number of poles must be greater than 0. Then only it is called a strictly proper transfer function. Then it is act as a low pass filter. In case poles less than 0, then it may act as a high pass filter. Then it is called improper transfer function. It is sensitive to the noise signal. It is especially sensitive to the noise signal. So be remember, control systems are basically low pass filters. Why they designed control systems as a low pass filters means to get the desired and accurate output, which is possible by eliminating the high frequency noise signal. That's why in the standard form of a system, they included n low pass filters. So next, so transfer function. Get the screenshot, this all of you. Get the screenshot. All of you get the screenshot. Next, transfer function. What is a transfer function? What is a transfer function? It is a mathematical equivalent model of the system. It is a mathematical equivalent model of the system. Mathematical equivalent model of the system. It is a mathematical equivalent model of the system. Transfer function is basically mathematical equivalent model of the system. System and transfer function both are same. You say the transfer function, you say the system, both are same. If you studied network synthesis, in network synthesis, they used to give a system, they used to ask, they used to give the transfer function. The given data is transfer function. They used to ask design a system, means draw the network. They used to ask it. For example, I'll take a transfer function. I'll draw the network. For example, see. For example, I'll take a transfer function. That is 1 by R C of S by R of S equal to 1 by S plus 1. 1 by S plus 1. It is a transfer function. Once you look at transfer function, what is the first information you can get? Once you look the transfer function, what is the first information you can get? First information, order. Order of the system. Order of the system. Order of the system. Order of the system. What order indicates? Order represents the number of storage elements. Number of storage elements. Elements are number of time constants. Number of time constants. Number of time constants. So order represents the number of storage elements or number of time constants. Number of time constants. Okay. So for example here, if you observe the order, first order system, it is order 1. That means there should be a single storage element. There should be a single storage element. So that means what are the practical single storage elements? Practical single storage element. So RLC, we are discussing about the linear circuits, linear control, just RLC. Single storage or single time constant circuits are what? We can say RC circuit. So this is single time constant system. It is a single time constant system. It is a simply RC network. Here VI, V0, RC. It is a single time constant system. So here you find a transfer function to this. First what I did, I taken a transfer function, identify the order, based on order, identify number of time constant. Because it is a single time constant, single storage element, I take an RC network. I take an RC network because single time constant means RC network or RL network. We can take even RL network also. But whatever you take, it should be a low pass filter. Now you find a transfer function. So VI of S, V0 of S, Laplace of capacitor 1 by SC, Laplace of resistor R. So what is the transfer function? V0 of S by VI of S equal to, transfer function means impedance across output by total circuit impedance 1 by SC by R plus 1 by SC. To find the transfer function, you will get 1 by SCR plus 1. Tau equal to what? RC. Tau equal to RC. That means, what is the transfer function you got? V0 of S by VI of S equal to 1 by S tau plus 1. So that means I got the what? First order system here. So first I taken a transfer function from that order, from that system identified. Then to the system I find transfer function. Then I find the transfer function. 1 minute. One minute. Okay. 1 minute, 1 minute. Right. So here transfer function is 1 by s tau plus 1. Now I can compare these two. Just compare these two transfer functions. Audible, na? Audible, na? Is it audible? Is it audible? Yes or no? Is it audible? Yes, okay, okay. 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 Listen. So compare these two. If you compare the transfer function, then what is the tau value got it? What is tau? Tau equal to 1 second. Tau equal to 1. Tau equal to 1 second. That is nothing but RC. That is nothing but RC. In case I will select R is 1 mega, the C must be 1 micro. Then the product should be 1. That means R is 1 mega, C is 1 micro. Now what I can say that this transfer function is nothing but whatever the transfer function is there, this transfer function and this system both are same. Either you write 1 by s plus 1 or either you draw this RC network, both are going to be same. Either you write the transfer function 1 by s plus 1 or either you draw the RC network, both are same because both are giving 1 by s plus 1 only. So transfer function is a mathematical equivalent model of the system. For example, if you want to find the performance of this system, for example, they'll ask find unit step response. For example, just for understanding, listen. For example, why we are going for the transfer function? Why we are going for the transfer function, for example? So I want to find the speed of this particular system or settling time or speed of this particular system. So if you give RC network, for example, RC network is given. I want to find a speed of this particular system. Speed means raise time and settling time you have to find. For example, they given here 1 mega, 1 micro. To find the speed, we require to apply some signal. For example, step signal we have to apply. So on the paper, on the board, to the RC network, if we connect a source, is it gives the output? It cannot give the output. So it is not possible to find the performance of this RC network on the paper or on the board. It is possible only in the laboratory. We need the equipments to want to find a speed and accuracy or all the parameters. We need equipments, but in the class it is not available. Then how can you check the performance? So to check the performance, first thing we need is what? Transfer function. So once you find a transfer function, for example, what is the transfer function to this? So 1 by s plus 1. We find it. 1 by s plus 1. How is 1 means what happened here? This is nothing but 1 by s plus 1. It is nothing but 1 by s plus 1. Tau equal to 1 na? It is nothing but 1 by s plus 1. I want to find a settling time or speed. Then I have to apply step input. What is the, I will take a mathematical model of a system is 1 by s plus 1. Mathematical model of a input is 1 by s. Then what is C of s? 1 by s into s plus 1. You find a partial fractions, you will get 1 by s minus 1 by s plus 1. Then apply inverse Laplace transform. C of t become 1 minus e power minus t into u of t. That means we got the output waveform here. We got the response. We got the response for this circuit. So the next level of the system is nothing but transfer function. The first thing always we have to learn it, how to write the transfer function to the system. Then only we can do the analysis on the paper. Unless until you write the transfer functions to the system, we cannot do analysis on the paper. It is not possible. So then I'll draw the response. What is the response for this? This is t. This is C of t. T0. T0 means, so T0. So T0 means what I will get? E power 0 is 1, 1 minus 1, 0. T infinity. So 1, that means exponentially rise to 1. Then I can say this is the duration of 5% to, for example, 10% to 90%. This is the duration of rise time. And this is the duration of settling time. Then I can find the what performance of the system. So when you want to find the performance of the system, any system performance, accuracy, anything you want to find, first requirement is we have to write the transfer function. So then like this, we can verify theoretically. This is theoretical analysis. This is theoretical analysis. Same thing we can check in the laboratory. You can connect RC components on the breadboard. We can connect the RPS, regulated power supply of 1 volt. So we can check the output signal in CRO. Then we can check it theoretically, practically, answers either matching or not. So like this, we have to do the analysis of the system. So whenever you want to check the performance of the system, or theoretically especially, first step we need is transfer function. So transfer function is mathematical equivalent model of the system. The physical system equivalent mathematical model is nothing but what? Transfer function. Be remember, transfer function is a mathematical equivalent model of the system. Transfer function is the other word for the system. You say system, you say transfer function, both are going to be same. Okay. Get the screenshot. Get the screenshot. I will clarify the doubts at the end. Any doubt is there, I will clarify at the end. Okay. Okay. Right. So next, get the screenshot this. Get the screenshot. Next, block diagrams. Block diagrams and signal flow graph. Why we have to study block diagrams and signal flow graphs? Why we require to study block diagrams and signal flow graphs? So what is the main objective means? To find overall transfer function of the system. To find overall transfer function of the system. Overall transfer function of the system. To find overall transfer function of the system. Overall transfer function of the system. So, for example, if you take industry, it occupies the acres of land. So big models will be there. So you want to find overall transfer function. You want to find transfer function of industry. It is not possible with the transfer function analysis. Then you have to go for block diagrams and signal flow graph. For example, if you take some industry, you may have here, this may be input. It may be step down transformer. Output of the transformer may be connected to some rectifier, or it may be connected to some regulator. It may be connected to some output, for example, regulator. So how to find the transfer function of this system, for example, we have to write a mathematical equivalent model for the transformer first. You have to write the mathematical model, that is like G1 of S, next rectifier G2 of S, next regulator G3 of S, like this individual transfer function you have to find. Then based on the inputs and output, we have to make the connections between the blocks. Then you have to find the overall transfer function by using block diagram reduction techniques or signal flow graph analysis. So the by using transfer function analysis, we can find transfer function of simple systems, simple blocks, a simple module, simple things. But whereas you want to find a transfer function of industry, we require a block diagram or signal flow graph analysis. Whatever it is in the first chapter, we are going to learn the writing the mathematical equivalent model of the system. In the first three topics, transfer function, block diagram, signal flow graphs, what we learn means writing the mathematical equivalent model of the system. Just mathematical expressions we are writing. Just we are finding the transfer function, that's all. That is nothing but writing the mathematical equivalent model of the system. The first step, we are going to learn how to write the mathematical equivalent model of the systems. Next, come to the second topic. Second topic is time domain analysis. Time domain analysis. Time domain analysis. What is the need of this chapter? First chapter, we required to get the mathematical expressions for the system. Second chapter, why we required, why we need this time domain analysis. What is the main objective of this? Main objective is to evaluate the performance of the system. To evaluate performance of the system. To evaluate performance of the system. To evaluate performance of the system. You have to evaluate the performance of the system. So what we'll do here? What we'll do here? First here in this chapter, first what we did? We written a transfer function. Other word for transfer function is system. Other word for the system is mathematical equivalent model of the system. Once you get mathematical equivalent model, the second step what we are going to do is, we are going to apply different inputs. We are going to observe the output. We are going to apply different inputs. We are going to different inputs, and we are going to observe the output. What are the different inputs? First one, impulse. The different inputs are, first one, impulse. Impulse we can apply. Next step. Next ramp. Next parabolic. Ramp. Next parabolic. We'll apply the different input signals. We'll apply the different input signals R of t, and we'll draw the output. Whenever you apply this non-sinusoidal signals, then if you observe the output, The output varies with respect to time. The output varies with respect to time. The output varies with respect to time. Once the output varies with respect to time, then we can do the analysis with the time. That's why it is called time domain analysis. That's why it is called time domain analysis. So here the response, the output varies with respect to time. As the response varies with respect to time, we can observe the many factors like delay time, we can observe the delay time, next rise time, peak time, settling time, percentage of peak overshoot, steady state errors. Like this, we can observe the many factors. Like this, we can observe the many factors. By knowing all these factors, we can decide what type of system it is. By knowing all these factors, we can decide what type of system it is. For example, see, if delay time, rise time, settling time, all are very, for example, large. All these factors are very large. What I can say, it is slow response. We can say that the system is giving a what? Slow response. For example, peak overshoot is very large. For example, peak overshoot is very large. If it is very large, what you can say? If a large peak overshoot, what you can say? More oscillations. Large peak overshoot means more oscillations, and less relatively stable. Less relatively stable. So the system should not have the large peak overshoot. If it is having large peak overshoot, the system become more oscillatory and less relative stable. Steady state errors. Steady state error in case very large. What we can say? Error very large means less accurate. Steady state error very large means system is less accurate. That means by observing the performance, by observing the output with respect to time, we can decide the system performance. Either it is slow response, either it is a less relative stable or more relative stable, either it is more accurate or less accurate. We can identify the system performance. So this is about the time domain analysis. In the time domain analysis, we will apply the different types of input signals and we'll check the performance of the system. But what about sinusoidal signal? In case you applied a sinusoidal signal, for example, what happened? If you apply a sinusoidal signal to any LTI system, if you apply a sinusoidal signal, the output also sinusoidal only. The output sinusoidal only. The difference is magnitude and phase. Here, no variation in the output with respect to time. Output not changes with respect to time. Output not changes with respect to time. That means we cannot do analysis with respect to time. We cannot do analysis because output is not changing with respect to time. Output is not changing with respect to time. Output not changing with respect to time. That means we cannot do analysis with respect to time. Then what happened? Output waveform, input waveform shape is same. Just to change magnitude and phase only. Frequency same. Output frequency, input frequency same. So then what you have to do? You have to vary the input frequency. You have to observe the magnitude and phase. With input frequency, magnitude and phase is changing. That means with frequency, we are observing the magnitude and phase. This is called the frequency domain analysis. This is called the frequency domain analysis. So what is the frequency plot? Observing a magnitude with respect to frequency, phase with respect to frequency is called the frequency response. If somebody asks define frequency response means observing magnitude and phase for different frequencies and drawing a magnitude plot with frequency, phase plot with frequency is called the frequency response. Is called the frequency response. Okay. Okay. Next. So this is about the frequency response. Get the screenshot this. All of you get the screenshot. Get the screenshot. Next. Next. Okay. Next, go for the stability. Next, go for the stability. Stability. So these stability techniques are very, very important. The stability techniques are basically to find the closed loop system stability. Stability techniques are basically to find closed loop system stability. Closed loop system stability. The stability techniques are basically to find closed loop system stability. We don't require any stability technique for open loop system. We don't require any stability technique for open loop system. Why we don't require any stability technique for open loop system means directly we can identify the open loop stability. Open loop stability directly we can identify by looking at transfer function itself. But we cannot identify the closed loop system stability directly by observing the transfer function. That's why all the stability techniques are basically to find the closed loop system stability only. Before this, all of you all should know one thing. Basically, you take any system. It is very, very important. Listen, all of you. Basically, you take any system. Any system you take. It may be open loop system. It may be closed loop system. You take any system. It may be, for example, okay, first I'll take one question for example. One more thing, listen, well, all of you. For example, you take one question. In case exam, in the exam they ask a question like this. The open loop transfer function of A, the open loop transfer function of a unity feedback system. Unity feedback system. Unity feedback system is 1 by s plus 1. Sorry, for example, 10 by s minus 2 you take, for example. The open loop transfer function of a unity feedback system is 10 by s minus 2. The system is option A, stable, option B, unstable, option C, marginal stable, option D, conditional stable. What is the answer, anybody? Anybody, what is the answer? Is it stable or unstable? So here, first of all, here, you should be perfect in identification of system. You should be perfect in identification of system. Either given system is open loop or closed loop. Is it open loop or closed loop? Given system. Given system, open loop or closed loop? Anybody answer? Very good. Some people are telling open loop, some people are telling closed loop. That means you are not perfect in identification of system. Listen. Either it may be open loop system or closed loop system. All are defined in terms of open loop transfer function only. Closed loop system also defined as open loop transfer function. And open loop system also defined as open loop transfer function. How to identify either it is open loop or closed loop means observe the feedback. You observe the feedback. Feedback exists means basically it is a closed loop system. Feedback exists means basically it is a closed loop system. If there is no word of feedback, then it is open loop. If the feedback word is there, then it is a closed loop. Feedback word is there means it is a closed loop system. Feedback word is there means closed loop system. If you have any doubt, draw a diagram. Open loop transfer function means G of S. Put in a block, open loop transfer function G of S, which is having a unity feedback. Unity feedback means it is from output to input. It is having unity feedback like this. Then default feedback is negative feedback. Input R of S, output C of S. Which system it is? Closed loop system. So that means you have to identify closed loop stability. To identify, because it is a closed loop system, we require to find closed loop stability. For that required closed loop transfer function. What is the closed loop transfer function? C of S by R of S equal to G of S by 1 plus G of S. Closed loop transfer function is G of S by 1 plus G of S. This is the closed loop transfer function. What is G of S? 10 by S minus 2. So 10 by S minus 2 divided by 1 plus 10 by S minus 2. Simply add the numerator term in the denominator. Simple logic is 10 by S minus 2 na. To find a closed loop transfer function, add the numerator in the denominator. Automatically it becomes closed loop transfer function. How it is means I'll discuss later. Just add a numerator term in the denominator. Automatically it becomes closed loop transfer function. Then what happened? 10 by S plus 8. Whole at where? Minus 8. That means the system is stable. That is the pole location. Pole location is S equal to minus 8. That means the given closed loop system is 100% it is stable system. It is a stable system. So that's why you be perfect in identification of system. How to identify means just observe the word of feedback. Observe just word of feedback or letter of H of S. H of S is there, feedback word is there, then it is a closed loop system. There is no H of S, there is no word of feedback, then we can say it is a open loop system. For example, that's why what I want to say, listen all of you. You take any system, it may be open loop system, it may be closed loop system. It may be open loop system, it may be closed loop system. Any system you take. Any system you take. Any system you take, it is defined as open loop transfer function only. It defined as open loop transfer function only. Open loop transfer function. Closed loop system also defined as open loop transfer function. Open loop system also defined as open loop transfer function only. Open loop system defined as open loop transfer function of a system. Open loop transfer function of a system. Open loop system defined as open loop transfer function of a system. Simply, that's all. Closed loop system defined as, that means here it is G of S. It is called G of S. Open loop system defined as G of S. That is called open loop transfer function of a system. That is called open loop transfer function of a system. Closed loop system also defined as G of S only. Here also G of S only, but it is called open loop transfer function of a unity feedback system. Unity feedback system. Unity feedback system. And indirectly mentioned H of S equal to 1. Indirectly mentioned H of S equal to 1. Both are G of S, both are open loop transfer. What is the difference? Here feedback word is there. You search for the word of feedback. You search for the word of feedback. In case non-unity existed, then closed loop system defined as G of S, H of S. In case non-unity exists, in case non-unity, then it is defined as G of S, H of S. It is called open loop transfer function of a non-unity feedback system. Non-unity feedback system. It is called open loop transfer function of a non-unity feedback system. You search for the word of feedback. Feedback is there means that is a closed loop system. H of S is there means that is a closed loop system. H of S is there means that is a closed loop system. Other word for this G of S, H of S is loop gain. Another word for the G of S, H of S is loop gain. Even loop gain is there, then also it is called a closed loop system. Wherever you see the word of loop gain, word of now open loop transfer function of non-unity feedback system or unity feedback system, so then it is called a closed loop system. Closed loop system always having a letter of H of S or having a word of feedback, or it's a loop gain. But when you come to the open loop system, simply it is open loop transfer function or open loop transfer function of a system, that's all. So open loop transfer function or open loop transfer function of a system, that's all. Okay? So like this, you have to identify the given system. If it is a closed loop system, again you require to find the closed loop transfer function. If you open loop system, directly by observing open loop transfer function, we can find the stability. Okay? Get the screenshot this. Get the screenshot, all of you. Get the screenshot. Okay? Next. Why we don't require any stability technique for open loop system? Why we don't require means, listen. Why we don't require any stability technique for open loop system means, if I take a open loop system, it is defined as open loop transfer function of a system. It is defined as open loop transfer function of a system. Open loop transfer function of a system. So, for example, I'll take open loop transfer function of a system is G of S equal to, for example, S plus 1. Satyam. S plus 1 divided by, for example, S plus 2 into S something, for example, I'll take S minus 4. Is it stable or unstable? Anybody? Is it stable or unstable? Is it stable or unstable? Bolo, is it stable or unstable? So what happened? One pole in the right, that means it is unstable. So for example, if I put it here plus, it is stable. For example, if I put it yes here, marginal stable. If I put S square, then it is unstable. Repeated poles means unstable. See, I didn't apply any stability technique here. We didn't apply any stability technique. Directly we identified stability because we are able to identify the directly poles location. Two poles at origin. Directly I can say unstable, one pole at -2, one pole at -4. It is unstable. Directly I can say open loop system unstable because we are able to identify the open loop pole location. So directly we will identify open loop pole location so that we don't require any stability technique for open loop system. In case here you are unable to identify open loop pole location, then we can use RH criteria. We can find the open loop stability also, nothing wrong. But when you are able to identify the open loop pole location directly, we don't require any stability technique. As per the norms, the system always defined in terms of time constant form or pole zero form. Either it is 1 plus S tau form called time constant form. This is called pole zero form. In any form, we can identify directly pole location. So if we give expanded form, we cannot identify. Then we have to use the what? Stability technique. But basically, you observe anywhere question. Generally, they'll give in a factors form like this, time constant form or pole zero form. So that we can identify directly poles location, directly we can identify the open loop stability. Why we don't require any stability technique for open loop system? In simple reason, open loop pole locations, open loop poles locations are identified directly, are identified directly, hence no stability technique required, hence no stability technique required to find open loop stability. To find open loop stability, open loop poles locations are identified directly, hence no stability technique required to find open loop stability. When you go for closed loop system, when you go for closed loop system, when you go for closed loop system, so closed loop systems are defined as what? Closed loop system defined as open loop transfer function of a generally standard feedback is unity feedback system. Open loop transfer function of a unity feedback system. For example, I'll take same thing. G of S equal to S plus 1 by S square into S plus 2 into S plus 4. S plus 1 by S square into S plus 2 into S plus 4. Now, is it stable or unstable? What it is? We don't know. We don't know either it's stable or unstable. What it is, we don't know unless until you write the closed loop transfer function, because it is a closed loop system. So then I'll write the closed loop transfer function. So simple logic, what I told, G of S by 1 plus G of S, that equal to S plus 1 by, so expand the denominator, S power 4 plus 6S cube plus 8S square. Just add the numerator in the denominator, S plus 1. Now tell, this is the closed loop poles, S power 4 plus 6S cube plus 8S square plus S plus 1. What are the closed loop pole location? Tell. You tell the location of closed loop poles, anybody? Okay. Come on. Anybody? Can you find the location of poles here? It is not possible because higher order. Up to second order, okay, we can identify. Third order still we can find by using calculator. Fourth order, fifth order, sixth order. Is it possible to find the location of poles? Not possible. That means we required a technique to find the stability. Closed loop poles locations not identified directly. Closed loop poles locations not identified directly. Not identified directly. Hence required, and hence we cannot find closed loop stability. Hence required a stability technique. A stability technique to find closed loop stability. To find closed loop stability. To find closed loop stability. So why we require a stability techniques for closed loop means we cannot find closed loop pole location directly. That's why we require a stability techniques for closed loop. But whereas open loop pole location directly we are identifying. That's why we don't require any stability technique. Closed loops are not identifying. That's why we require a what? Stability technique for closed loop. Okay. So this is about the why we required a stability technique for closed loop system. Next, again, in the closed loop systems techniques, we are having a time domain technique as well as frequency domain technique is there. Time domain techniques are RH criteria and root locus. Frequency domain is Bodo plots and Nyquist plots. Among these four techniques, which is the best means what you can say? The first priority in a stability technique is Nyquist plot. The first is Nyquist plot. Actually, why the frequency? According to, listen, when you talk with respect to stability, which is the best technique? We are having two techniques now. One is time domain technique. The second one is frequency domain technique. So among these two, for stability especially, which is the best technique means you can say frequency domain. Frequency domain technique is the best as compared to the time domain technique. Stability point of view, the best is frequency domain as compared to time domain technique. Overall performance you want, complete analysis of the system, the best is time domain technique. Complete analysis of the system means stability, speed, accuracy, everything you want, the best is time domain. Whereas only stability analysis, the best is frequency domain. Only stability, the best is frequency domain. Okay. For complete analysis, time domain. Why stability? Why the time domain best? Mean time domain we can do the transient analysis as well as steady state analysis. Whereas frequency domain is nothing but simply steady state analysis because input is sinusoidal, output also sinusoidal. That means, so time stability analysis is a steady state analysis. Whereas time domain gives the transient, that's a complete analysis means time domain best. Only stability frequency domain. Why the frequency domain best means, listen, Get the screenshot? Next. Why the frequency domain is best? Why the frequency domain best means, listen. For example, I'll take a time domain technique. For example, Rx or root locus, I'll take, for example. I'll take the RH criteria or root locus, whatever it is. So it is a time domain technique. Time domain technique. Time domain technique. RH or root locus. You take. I'll take transportation delay system. Example, transportation delay system. Transportation delay. Transportation delay system. Like the function is g of t minus tau. Tau shows the delay. Tau is a delay. Tau shows the delay. So I will apply Laplace, for example, to this. Then what I will get? E power minus s tau into g of s. E power minus s tau into g of s. So e power minus s tau is represents the delay in the system. Tau shows the delay in the system. Tau is delay in the system. I want to find the stability of e power minus s tau, transportation delay system. So what is e power minus s tau? What is the pole location for e power minus s tau? Unless until you know the pole location, we cannot find the stability. What is the pole location for e power minus s tau? Anybody? Not possible. E power minus s tau, pole location, not possible. Is it possible? Anybody? Not possible. So what you have to do? You have to expand 1 minus s tau plus s tau square by 2 factorial minus and so on and infinity. Now can you find the stability of this term? No, infinite series you cannot find the stability. Then what you have to do? What you have to do? You have to neglect the higher order terms. Neglect higher order terms. Once you neglect, then the analysis is called approximate. Once you neglect, the analysis is called approximate. That means we can find approximate stability condition. Approximate stability condition is obtained. Approximate stability condition is obtained. Approximate stability condition is obtained. It is not possible to find exact stability. It is not possible to find exact stability. It is possible to find only approximately stability condition. Approximate stability condition. That is a drawback with what? Time domain technique. When you want to find a stability of a transportation delay systems by using either RH or root locus, that is called approximate only but not exact. When you go for frequency domain, technique, either it may be Bodeau plots or Nyquist plot, whatever it is. In the Bodeau plot, we'll draw two plots. What are that? Magnitude versus frequency and phase versus frequency. Phase versus frequency. Whereas Nyquist plot is what? Magnitude versus phase. Magnitude versus phase. Nyquist plot is magnitude versus phase. So now, what is required here? Magnitude and phase is required. We required magnitude and phase. E power minus s tau. E power minus s tau. What is the magnitude for e power minus s tau? What is the magnitude? So it is 1. Magnitude is 1. What is the phase angle? S replaced by j omega, na? If you replace s by j omega, what I will get? E power minus j omega tau. E power minus j theta. E power J theta means what, man? Cos theta plus J sin theta. So that means what happened? What is the magnitude? Cos of minus omega t plus J sin of minus omega t. What is the magnitude? 1. It gives magnitude 1 and phase angle of minus omega t. Phase angle minus omega tau. That means exact magnitude you can find, exact phase angle you can find. We can find exact magnitude, we can find exact phase. So that means we can find exact stability condition. Exact stability condition is obtained. 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 So that's why frequency domain technique is the best as compared to the time domain technique, especially for stability. Again, we are having 4 techniques. So which is the first priority means Nyquist plot. In the frequency domain, the first priority is Nyquist plots compared to Border plots. Why first priority for the Nyquist plot means Nyquist plot gives the stability of all the systems. It gives closed loop stability of all the systems. All the systems means it may be minimum phase system or it may be non-minimum phase system. It may be all pass, any system, whatever the system it is. So it gives the stability of all the systems. When you go for Border plots, when you go for Border plots gives the stability of only minimum phase system. Stability of only minimum phase system. That's why it is third priority. 1 minute. Priorities. This is third priority. Border plot is third priority. Second priority is root locus. Second priority is root locus. Fourth priority, last priority is RH criteria. Least priority is RH criteria. These are the 4 techniques. Why the second priority to the root locus means root locus gives the nature of the system. Nature of the system. That is the main advantage. Nature of the system. Undamped, underdamped, critical damped, oscillatory, non-oscillatory, what type of the system it is, that is identified by using the root locus. That's the second priority given. First priority root locus, Nyquist plot, because it gives the stability of all the systems and it gives the range of K for stability, range of K for stability and number of closed loop poles, right? Number of closed loop poles, right? And even you can find gain margin and phase margin. Here what you will find? Only gain margin and phase margin. That's why third priority. Here natures and range of K, all these factors we can find here also, the root locus. That's why second priority root locus. RH criteria just it gives the either stable or not, that's all. RH criteria gives either stable or not. Either stable or not, that's all. That's why this least priority to the what? RH criteria. The least priority RH criteria. This is about the priorities of stability techniques. Okay. Next. Get the screenshot. Next, go for the compensators and controllers. Compensators. and controllers. What is the requirement of compensators and controllers means? To get required specifications. To get required specifications. The customer gives the specifications. For example, you want some race time, certain speed you want. You will give specification means speed, accuracy, stability, like this. They'll give us some specification, sensitivity, some specification. Customer gives always specification. Then we have to design the system. You designed the system very nicely. Mathematically, you designed everything. After designing, you assembled the components and check the specification. Then it may not matches. Why? Because we cannot include the temperature effects on the theoretical calculation. Theoretical is ideal. Practical and theoretical, there is a difference. That's why it may not matches all the specifications. Theoretically maybe matches, but practically not matches. Then what we have to do? We cannot throw all the components. Then what they'll do? They will add these compensators and controllers. What is a compensator controller? Means it is a simple RC network. It is a simple RC network which adds the poles and zeros to the system at required location. Which adds poles and zeros location at required location. Compensator, mainly RC network, adds poles and zeros. Poles and zeros at required locations. At required locations. And so automatically what happens? You'll get the desired specifications. So this is the need of compensators and controllers. Compensator. For example, there is a problem in a speed. Generally, for example, there is a problem in a speed. The system giving very slow response. Then we require to add the what? Like high pass filters. We require to add high pass filter, like high pass filter. That means lead compensator. Lead compensator or PD controller, which improves the speed of the system. Which improves the speed. The problem of accuracy, for example. Accuracy. Then we have to add a low pass filter. That means lag compensator. Or PI controllers we require to add. In case there is a problem of stability in the system. If is there problem of stability, then again you have to add high pass filter. That is what lead or PD controller. Problem of all, for example, speed, accuracy, stability, speed and accuracy and stability. Accuracy, for example. Then we have to go for lag lead compensator or PID controller. So based on the problem, we have to add the what? Required compensator and controller to get the desired specifications. So compensators and controllers mainly need to get the required specifications. Okay. This is about compensator and controllers. Next, state space analysis. State space analysis. State space analysis. State space analysis mainly used for dynamic systems. Dynamic systems means the system may be linear or non-linear or time variant or time invariant. For all the types of the systems, we can use state space analysis. But in our syllabus, we are having only LTI systems, linear systems only. So that's why we'll write state space for only linear systems. But in this analysis, valid for all the types of the system. Transfer function analysis valid for only LTI systems. But whereas state space analysis valid for the what? Dynamic systems. This is the complete structure of control systems. Okay. So just a brief introduction of each and every chapter for what we are studying. First chapter, transfer function, block diagram, signal flow graph to write the mathematical equations for the system. Second one for analysis and to find speed and accuracy and stability. Third one is to find closed loop system stabilities. Fourth one to get the desired specifications. Fifth one is last chapter. But chapters, three same. Transfer function, block diagram, signal flow graph. All the three for just mathematical expression. Time domain analysis, evaluating performance. Stability to find closed loop stabilities. Compensator controllers to get required specifications. State space analysis gives the analysis of dynamic systems. So this is about the all the topics in the control systems. So now I'll start the subject. I hope you know about me. My name is Nageswara. Already I told it. If you have any doubt, even you can call to me. Not now. After the class, my contact number 98490 42722. Even you can send the WhatsApp to this 98490 42722. Now I'll start the subject. Okay. Today we'll discuss what is a transform, some basics. What is a system? What is a control system? Some basic concepts. Any doubts if there you can ask. Abhinav, Anubhav.
Yeah, sir. Actually, I don't have any topic related doubts. Just wanted to ask, like, sir, the PDF will get uploaded, no, sir?
They'll upload, I think.
Okay, then.
Previously, I used to say get the screenshot, but before subject they uploaded PDF.
Yeah. All the PDFs were uploaded before.
Then you don't need to get screenshot.
Okay.
If not uploaded, I think the previous subject uploaded, na?
Yeah.
Then they will upload, I think.
Okay.
I think they'll upload.
And sir, one more thing. After studying from you, sir, would we need to buy books and all? I mean, the books you mentioned.
I don't think it is required. Our material, 2 volumes is there, na? Control system. Material do you have?
I have, because I am from previous batch, but I.
Okay. That material is all that questions. It is more than sufficient.
Okay.
Volume 1, volume 2, previous gate questions or IS questions if you solve, na? Is more than sufficient. And moreover, gate is more problematic. More than 99%, almost 100%, the questions are numericals only. So you need to practice more questions. Okay? Okay, na?
Yeah, yes, fine.
Okay. Sri Charan?
Sir, I had doubt in page number 5, sir.
Tell me.
Sir, here for closed loop, G of S is different, no, sir?
Why? What is closed loop G of S?
Okay.
Closed loop, there is no G of S. Closed loop transfer function is G of S by 1 plus G of S. That should be obtained from open loop transfer function.
Okay.
Systems
only transfer
basically
function.
they define in terms of open loop transfer function only.
Okay, sir.
To the system directly, we cannot write closed loop transfer function. Not possible.
Okay.
They'll write separately forward paths, that is called G of S, feedback path, that is called H of. Separately they'll write.
Okay.
From that you have to find the closed loop transfer function. Okay, na?
Okay, sir. Got it, sir.
Okay, ma. Anirudh?
Sir, while analyzing open loop transfer function, do we have to convert it to closed loop transfer function and find the stability, or directly?
Yes. We require to find, if you want to find closed loop stability, we require to write closed loop transfer function, na? Or you have to go for the stability techniques like root locus, GH we have to use. There in the root locus, Nyquist plot, Bordeaux plots.
Sir, but you told that we can analyze an open loop transfer function directly by looking at its transfer function.
There open loop also directly can identify. We can identify open loop stability directly. But closed loop stability cannot identify, na?
Yes, sir.
Closed loop stability required closed loop transfer function. Or you have to use the stability closed loop transfer function you have to write, and then you have to find closed loop pole location, which is not possible. Yes or no?
Yes, sir.
Then what you have to do? You have to use the stability techniques.
Yes, sir.
All the stability techniques use the closed loop stability only.
Yes, sir.
Okay.
Feedback affects pole locations.
Yes, that's why affects the pole location. That pole location you are unable to identify if order is more than 3.
Yes, sir. Sir,
Then how to find stability?
Sir, in time domain also, in time domain we can analyze the system peak overshoot and all, no, sir. Then
That is for only second order. Can you find peak overshoot for third order?
no, sir.
Well then,
I
okay.
have that doubt. Okay, sir.
Okay,
Thank
now. Okay, now I'll start the subject.
Sir, one small doubt, sir.
Tell man.
Sir, in frequency response, we can only find for sine and cosine, no, sir.
Yes, correct, 100%.
But we cannot find for unit step for all those. We cannot.
Then it will become time domain again.
Time domain. Oh, okay.
Okay, okay. Next, I'll start the subject. We'll discuss at the end. Okay. At the end, I'll give the time. We'll discuss it. Get the screenshot this. Next. First, system. What is a system? What is a control system? Define the system. What is the system? What is the control system? Defined system and control system. Defined system and control system. What is a system? What is a control system? So system is a group of the physical components. System is group of the physical components. Group of physical components arranged in such a way that it gives the proper output. Arranged in such a way that it gives the proper output. Whereas if you take a control system, it is also group of the physical components only, but arranged in such a way that it gives the desired output. Control system always gives the desired output. System always gives the proper output. System gives the proper output. Control system gives the always desired output. What is the proper output? Proper output means it may or may not be desired. For example, I'll take one simple. I'll take the fan, just for understanding. If you take a fan without blades, for example, you take a fan without blades. A fan without blades. Is it a system? A fan without blades. Is it system? It is not a system. It is not a complete system. It is not a system. Why? Because System means it gives the proper output. What is the proper output? What is the intention of designing? That should give it. What is the intention of designing a fan? It gives the airflow. If it gives airflow, then I can call it a system. For example, you are designing electric bulb. So you designed, very nicely designed the bulb, but if you forget to put the filament, what is the purpose of bulb? It should give the light, brightness. But if no filament is there, it cannot give the light. We cannot call it a system. System means it should give the objective of designing, especially. Should give the proper output. If we take without blades, it is not a system because no proper output. Because no airflow. No airflow means no proper output. No proper output. So that means it is not a system. Not a system. It is not a system. Same fan I'll take. A fan with blades, but without regulator. A fan without regulator. A fan without regulator. 1 minute. One minute. Right. A fan without regulator is a system. No doubt it is a system. Why it is a system? It gives the airflow. Airflow is a what? A proper output. But airflow, this airflow is desired or not desired? Whatever the airflow you are getting, it may be desired or it may not be desired. It is a constant airflow, proper output. Proper output. But that airflow may be desired, may not be desired. Proper output means may or may not be desired output. Proper output means may or, here I'll write better, may or may not be desired output. May or may not be desired output. May or may not be desired output. Proper output means may or may not be desired output. Then you take a fan with regulator. Fan with regulator is called control system. Is called control system. Why? Because it gives the desired airflow. It gives the desired output. What is the definition of control system? It is a group of physical components arranged in such a way that it gives the desired output by using the controller or regulation to the given input. The definition of control system is, control system definition is, it is a group of physical components. Group of physical components arranged in a such a way that it is a group of physical components arranged in a such a way that it gives desired output by using controller or regulator to the given input. To the given input. This is the definition of control system. It is a group of physical components arranged in a such a way that it gives the desired output by using controller or regulator to the given input. Next. Get the screenshot this. Next. Control systems again classified into two ways. Control systems again classified into two ways. One is open loop control system. The second one is closed loop control system. So control systems are classified into two ways based on controller action. Based on controller action. One is open loop control system. Second one, closed loop control system. Now I'll draw a diagram for open loop. Controller. Process. Output. Reference. This is open loop control system. Next, closed loop control system. Reference input, or if it means reference input, summing point, controller, process, output, feedback network, this is the block diagram for closed loop control system. Can you say one example for open loop and closed loop? Any example for open loop? Any example for closed loop? Anybody? Example for open loop? Traffic control. Listen. Some people are telling. Okay, right? Good. Listen. One simple example I'll take for open loop and closed loop is common. I'll take for open loop and closed loop is iron box. iron box. Istri pette. Press, we'll say press na istri to get the press the cloths. So I'll take that iron box example for open loop and closed loop. Why? Because in the market, it is available open loop type iron box as well as closed loop type iron box. Both are available in the market. Open loop type is available as well as closed loop type is available. Simply, we can say most of the automatic systems are called closed loop systems. Not all, but most of the automatic systems. All manual operated systems. All manual operated system basically open loop system. Manual operated systems. Manual operated. The man is essential to get that desired output. Here man essential to get the desired output. Here man is not essential to get the desired output. Here man compulsory. Here man is not compulsory to get the desired output. So here, for example, if I take iron box, what is the reference input for iron box? From iron box, what do you want? Temperature. Temperature is the reference input. Reference input means don't say power. Reference input means what you want from the system. Reference input means what you want, what we required from the system. That is called reference input. It is nothing but desired output. Reference input is nothing but desired output. What you write? Reference input is nothing but desired output. So what we want from the iron box? Heat, temperature. The temperature is a reference input. Temperature is a reference input. If you see the automatic iron box, there is a provision to select the different types of the cloths. One knob will be there to the automatic iron box. There is a knob. Around this knob, they used to write the different cloth names like linen, cotton, silk, wool, like these cloth names they used to write. Once you select the knob to some particular cloth, it selects the required temperature to get the iron of that particular cloth. If I select to the linen, then the temperature rises up to the required temperature to get the iron of linen cloth, and then it operated at the same temperature. This knob provides the reference input. For example, you take a remote for the AC. What we can do from the remote of AC? We can set the temperature. So I want 18 degrees centigrade. I want 18 degrees cooling. Then you can set that. That is called the reference input. That remote is called the reference input. So here in iron box, there is a provision of one knob to select the cloth's name. So we selected cloth. That means we select the reference input. So this knob provides the reference input. When you come to the controller, what is the controller in a iron box, automatic iron box means there is a relay. Controller is nothing but a relay. It is an automatic switch. Relay means what? It is an automatic switch. Automatic switch. Controller is a relay, which is called automatic switch. So relay again, normally closed relay will be there, normally open relay will be there. So automatic switch. This relay operated based on the error signal. Relay operated based on error signal. Error signal may be positive or error may be negative. Error may be positive. Error may be negative. It may be positive. It may be negative. So generally, this is relay. If it is positive, then it is on. If it is negative, then it is off. If error is positive, on. If error is negative, relay going to be off. Process. Process is, here filament will be there, which produce the heat. Process is here filament will be there, which produce use. Output is temperature, the measurable quantity of temperature. And feedback network. What feedback network consists? Sensors. Feedback network consists the sensors. Feedback network consists the sensors and some passive components also. It may consist the RLC components, passive components. So the sensor sends the output and feedback to the input. So that error is generated. By comparing with reference input, error generated. Based on error, controller may become on and off. Based on and off, the temperature, heat is either increase or decrease. So come to the, this is a what? Components in a closed loop control system. When you come to the open loop system, in the open loop system, first of all, there is no provision to select the reference input. There is no, here provision is there, but here no provision to select the reference input. No provision to select reference input. To select reference input. It is manually observed. It is manually observed. It is manually observed. What cloth you are doing the iron, how much temperature required, it should observe manually. It should observe manually. Here, like this knob, it won't be there here. So that we should observe manually. Which cloth you are doing the iron and how much temperature required, you should observe manually. Controller, relay, sorry. Controller, on and off switch, manually operated switch. Manually. On and off switch is simply operated switch. Manual operated switch, on and off switch. On and off switch. Switchboard switches or switchboard. Process, filament which produce the heat. Filament which produce the heat. Listen all of you, listen carefully. Then you can understand the difference between open loop and closed loop system. Listen all of you. So, this is about open loop system. First, I'll explain about closed loop, then we'll come to the open loop system. For example, it's set to the linen cloth. The required temperature is 100 degrees centigrade, for example. Reference input is 100 degrees centigrade. Initially, what is the temperature of the iron box? Anybody? It is initially generally what happened? Room temperature. Room temperature means around 23 degrees centigrade. Initially. Then the sensor sense the, initially the sensors sense the sole temperature of the iron box. The sole temperature of the iron box. It will be 23 degrees centigrade. Then it fed back to the input. 100 minus 23 means 77. That is positive. Positive means on. On means heat increases. Temperature go on increases. Certain duration go on increase. After some time, for example, reach to 99 degrees centigrade. Then what happened? Fed back. 100 minus 99. Still positive. Still on. Still it increase. Then it goes to, for example, it goes to 99 degrees to, it goes to 101 degrees centigrade, for example. Once it reaches 101, then 100 minus 101 means negative. Negative means off. Off means heat reduced. Heat reduced means it come back to 99. It come back to 99. It come back to 99. Once it come back to 99, then again it going to become positive. Again on. Again increase. Again it goes to 101. Once it goes to 101, again error is negative. Because 100 minus 101. Negative. Negative means off. Again heat decrease. Again it come back to 99. That means what happened here? This controller action always going to become on and off, on and off, on and off. At any instant you observed here, the temperature maintained around 100 degrees centigrade. At any instant you observed, it maintained temperature around 100 degrees centigrade. It's not allowed to decrease below 100. Below 100 means immediately on. It is not allowed to increase above 100. Above 100 means immediately off. At any instant observed, it maintained around 100 degrees centigrade. At any instant you observed, the temperature is around 100 degrees centigrade. The temperature around 100. Why? Because this controller action is completely depends on the output. This controller on and off action completely depends on output. Output more than required, off. Output less than required, on. That means this controller action is completely depends on the output. Controller action completely depends on the output. Then it is called a what? Closed loop control system. Closed loop control system, output depend, controller action depends on the output. Output more, off. Output less, on. No human being required. Automatically the controller position automatically changes. That's why I put it automatic. Most of the automatic systems are closed loop, but not all. If you take washing machine, automatic washing machine, it is not a closed loop control system because the automatic washing machine is not having a provision of reference input. We cannot select the reference input, how much percentage cloth should be washed. Even there is no sensor in washing machine to sense the either cloth is washed properly or not. Sensor should sense the output, na? Output is washed cloth. But how much percentage washed? So you cannot sense it because there is no sensor in the washing machine. That's why washing machine is open loop. It is not a closed loop type. Closed loop system means it should have a sensor that should be sense the output. That should be measures the output. Then only it is called closed loop. Another thing, in close, when it is called a closed loop control system, means the feedback network should be connected from output to reference input. Then only it is called a closed loop. Output to reference input. Then only it is called a closed loop. Otherwise, we don't call it as a closed loop system. When you come to the open loop system, for example, you are doing the iron of some cloth, your favorite cloth, you are doing iron. You are doing iron, your favorite cloth. You switch it on the iron box. You switch it on the iron box. Then suddenly, phone call came, for example. Suddenly, phone call came. Generally, what happened? Wherever you go, our cell phone follows. By default, cell phone follows wherever you go. Just we'll go 1 feet away from the home, immediately we'll check either cell phone I taken or not. Phone call come. Then you attempted phone call. Then what happened? Then that also called some dearest person. For example, we consider a dearest person called close friend called. Then what happened? You'll go on talk it. Then you forget about either iron box on or off. You forget about the iron box. You don't remember. While go on talking iron box, what happened? While go on talking, then what happened? The temperature, heat is go on increases. Then after some time, what happened? Temperature behind the range, then what happened? The filament will blown out. Yes or no? The filament will be blown out. Then the iron box is spoiled. Yes or no? That means what happened here? What you observed here? Even though temperature behind the required level, it is not automatically switched off. Temperature still go on increasing. That means this controller action is completely independent of the output. Controller action is completely independent. Even though temperature increasing behind the range, it is not off. That means it is independent. The controller action is not depend. The controller action is not depend on the output. It is independent of output. Any open loop system you take, the controller action independent of output. No sensors are there here. As the temperature more or less, we cannot measure it. Whenever controller action independent of output, then it is called a open loop control system. Controller action depends on the output, then it is called a closed loop control system. For example, if you take four-way junction, for example, you take a four-way junction. This is the traffic signals, for example. This way, heavy traffic is there, for example, heavy traffic. This way, no traffic, for example, no traffic. Even though here existed heavy traffic, the duration of the lights are not going to be increased. Because of the heavy traffic, the duration, it is not going to be increased automatically. Because of the no traffic, the duration of the signals, the duration of the traffic control signals not decrease. That means this traffic control signal action is independent of clearance of traffic. The traffic control signal action is independent of clearance of traffic. That means it is a what? Open loop control system. It is a open loop control system because no sensors are there to sense the traffic density. For example, you put here sensors for 200 meters or 300 meters, put the sensors to sense the traffic density. Based on the traffic density, for example, the controller sensor sense the traffic density. Based on the controller, based on the traffic density, the controller change the duration of the lights. Then we can say it is a what? Closed loop control system. But at present, existed traffic signals are open loop type because they didn't arrange any sensors. So it is a open loop type. Again, so traffic control signals are what? Open loop type, because simply whenever there is no sensors or exist blindly, we can say it is a what? Open loop control system. Closed loop control system means, first of all, sensors must be exist. And closed loop control system must having this reference input. Closed loop system means it should have a reference input. So open loop system not having any reference input. Simply, what is the definition of open loop system? Get the screenshot this. Next, refer open loop system. Example. What is the open loop system? A system in which the controller action is independent of output. A system in which the controller action is independent of output, then it is called open loop system. Examples. Example, what we can take? Open loop system example, tell traffic lights, washing machine, because washing machine is not having sensors to sense the cloth washed properly or not. Next, any more? Fan, lights, air coolers, and so on. Any system which is not having sensors and any system which are not having sensors and provision to select the reference input. Provision to select reference input. To select reference input. What is the closed loop control system? A system in which the controller action is depends on the output. Depends on the output. A system in which the controller action it depends on the output. Example. Automatic iron box. Human being having 5 sensors. All the human beings are closed loop only. Human beings. Next, AC, air condition. AC is a closed loop system. Next, any more? And so on, refrigerators, fridges, refrigerators, and so on. Any system which is having provision of reference input, reference input and sensors. Closed loop system means compulsory it should have a reference input and sensor. Then it is called a closed loop control systems. Next, what about feedback network? Feedback network. What is the purpose of feedback network? It consists the sensors. What is the purpose? Feedback network. It is a property of closed loop system. It is the property of the closed loop system. It is the property of the closed loop system which brings output to input. Which brings output to input. Hence, error generated. Compare na. It brings output to input and compared. Error is generated. Hence, error is generated. The controller action takes place such that the controller action takes place such that error becomes the 0. Error becomes 0. So feedback network, it is a property of closed loop system. So once the output signal bring back to the input, compared means error generated. Based on the error, controller position change. So based on that, the error becomes the 0. Get the screenshot? Next. So feedback network consists the sensors, basically. Feedback network consists sensors and passive components. What is the maximum gain of feedback network? Maximum gain of feedback network ratio is? Maximum gain of feedback network ratio. Feedback network ratio is 1. Ratio is 1 because RLC circuit, maximum gain 1. Best feedback is? Best feedback Which is the best feedback? Unity negative feedback. Unity negative feedback is the best. Why is the negative feedback best? Negative feedback, why best? Negative feedback improves the relative stability. Improves relative stability means the pole shifted toward the leftmost side. But under the condition that loop gain means G of S, H of S should be greater than 0. Positive. Loop gain should be greater than 0. Loop gain should be greater than 0. Under the condition that loop gain should be positive. So if you loop gain greater than 0, the pole is going to be shifted toward the left. For example, see, I'll take G of S equal to 1 by S plus 2. H of S 1. Then what is the closed loop transfer function? Just add a numerator in the denominator, 1 by S plus 3. See, compared to minus 2, minus 3 is leftmost. This is minus 2. Minus 3, that means pole shifted left. That means more relative stable. Negative feedback improves the relative, but GH, this product should be positive. See, G and H product is positive. Substitute any value of S. Any value of S means omega value substitute, it should be positive. In case I'll take G of S negative like minus 1 by S plus 1, S plus 2, H of S 1, that means GH is negative here. If I write closed loop transfer function, I'll get minus 1 by S, add the numerator term in the denominator S plus 1. That means less relative stable. Here more relative stable. More relative stable means when GH is greater than 0, more relative stable. Here GH is what? Less than 0. Less relative stable. Loop gain when it is greater than 0, the negative feedback always improves the relative stability when loop gain is greater than 0. It should be greater than 0. Okay. And why unity feedback required? If it is unity, then only we can generate, then only we can get the exact error. For example, here system G of S is there. Here output is there. Here input is there. Then here error is generated. Here if it is unity, then exact signal come to the input. The same output come to the input. So that exact error is generated. So that exact error is generated. That means the best feedback is unity feedback. Errors are steady state, errors are valid for only unity feedback system. Steady state errors are valid for unity feedback system. Steady state errors are valid for only unity feedback system. Steady state errors are valid for only unity feedback systems. If a non-unity given, again it should be convert into unity, then you have to get the steady state error. So that's why the best feedback is unity negative feedback. Okay. So this is about the open loop and closed loop control systems. Okay. Next we have to start the transfer function. A transfer function. Then definitions. Two definitions are there. Before that, any doubts if there you can ask? Any doubt? You can raise the hand if you have any
Sir.
doubt. Tell.
Hello.
Tell, man.
Sir, how human beings are closed loop, sir?
We are having sensors or not?
Okay.
For example, you are driving a bike.
Yes, sir.
How will be the speed? How speed is controlled?
By
The
assume.
eyes will sense the road and traffic, na?
Okay, okay.
The brain is a
Okay.
controller. In any system, man is included means that system itself closed loop. Either he knows or not.
Okay.
Open loop system plus a man included human being, then it is called manual control system. Because man is controlling, na?
Yes, sir.
Manual control system. All manual control systems are closed loop control systems. Open loop system means man should not include.
Okay.
Man included means again it become a manual control system, then manual control system of closed loop. Why? Because man will work like a feedback network. Man will sense the output and send the signal to the compared with the reference input. Controller gives the signal, automatically controller position, based on controller position, the output will changes.
Sir, but in iron box, man is present, no, sir.
Where is man present to check to control the temperature? Man is present, huh?
In normal iron box, if we are doing, we are present, no, sir.
Normal iron box is open loop.
Yes, sir, but
You switch
we are
on
only doing the iron.
listen, you switch on the normal iron box, automatic iron box. And in automatic iron box, set the reference input. Then both will leave. Then what happened?
Okay.
Open loop system, filament spoiled, na?
Yes, sir.
Here man is not required.
Yes, sir. Yes, sir.
What I
Okay.
told man is essential to observe the what, to maintain the desired output. Where?
Okay.
In open loop system. Man is always required in the open loop system to get the desired output. But whereas in closed loop system, man is not required to get the desired output.
Yes, sir.
Got it, na?
Yes, sir. I got it, sir.
Okay, ma, okay. Next.
Sir, in case of iron box, the output is heat, no, sir. So it will
Oh.
sense the heat and it will automatically come cool down, no, sir, in iron box.
Why it is cooled down automatically? Power is there continuously.
Yes, sir, if we turn on the power and switch on the iron box, it will reach to a particular temperature and then it reaches the cutoff, no, sir. So
Cut off means
is
what
it not-
happened?
Cutoff
Cut
means
off
the
means
iron box.
same temperature maintained. If 100 is there, for example, 100 I want, it goes to 101. Cut off means it come to the what? Below 100. Below 100 means immediately again on, na?
Yes, sir. If it like if the reference is above 80 degrees Celsius and the iron box is getting below 80 degrees Celsius, it will automatically turn on, no, sir. So it
Yes,
is sensing the
automatically
heat. And, yes, sir. If it reaches the cutoff, it
Cut off means what, man?
so it is sensing the output and controlling the input, no, sir. So is it not a feedback system? It is.
Why not feedback? Error is 0. You are telling error 0 condition. Hello?
Yes, sir. In case of iron
Error
box.
0 means same temperature maintained. That's all.
Sir.
Error 0 means that is not that it is going to become 0. Same temperature. Previously, whatever the signal is there, same. Whatever the output is there, same output is maintained.
Yes, sir.
Okay.
But is it not a closed loop system, sir? Then
it is closed loop only. We are bringing output to input, na? Error is there means it is a closed loop.
sir, but
In open loop, where is the error, man? In open loop, where is the error?
no error, sir.
Well then, how can you compare?
Then iron box is a closed loop system, no, sir. You told open loop.
Both
system.
are there. Open loop type is there, closed loop type is there. Reference input is there, then it is closed loop. Reference input not there, then it is open loop. Sensor should be there. Both the
sir.
types available in the market.
Okay, sir.
Okay. Next. Arunachalam.
Sir, one small doubt, sir. Sir, that S-plane you just said, right? How it is? How you are saying it is like stable, like more stable, like as you go left hand side?
Pole shift to the leftmost, then it is more stable.
So how we are saying that, sir?
It reaches steady state quickly. Now oscillations become very less.
Like, is there any? It's like a rule or like a condition, or is there anything meaning? Does it mean anything? How do you understand the significance?
Stability means less oscillations.
Oh, okay, sir.
For example, poles on imaginary, what happened? Oscillations, na marginal stable
Okay.
system.
Okay.
Oscillator studied na.
No, sir. Like
In analog circuits, oscillator studied na.
Okay, sir. Actually, I joined late on this, sir. There's no study.
Okay. Oscillator principle is poles bring to the imaginary. As it come to the imaginary, the system generate more oscillations, means less stable.
Oh, okay, sir.
Stability means what? Without any fluctuation, the output should be stable.
Okay.
Got it, na?
Yes, sir. Okay.
Next. Prathamesh. Bolo.
So, in the sinusoidal state space analysis, we have to always consider a frequency domain analysis. Is it correct?
I didn't get. Tell one more time.
So, for a sinusoidal signal, we have to consider frequency domain analysis.
Yes, correct.
Okay. If sinusoidal signal is given, then we will directly go to the frequency, no time domain analysis.
Yes, correct.
Okay. And sir, are we going to cover process control in this also?
No. Process control, another instrumentation sir will teach.
Okay, sir.
Okay, ma.
Thank you, sir.
Okay.
Sir,
Tell me.
sir, you told that if input is sinusoidal, output is also sinusoidal, no, sir, for any
Yes,
system.
correct.
Sir, in case of op-amp, if the input is sinusoidal, we'll get output square wave, no, sir, in that case.
Where you are operating, which region you are operating?
Saturation region.
But then automatically shape will cut it. It should be operated only in the linear because we are studying linear control systems, na?
Okay,
You have to
sir.
operate in active region. Active region you operate. Amplifier studied, na?
Yes, sir.
What happened? Input sinusoidal, output also
Sinusoidal.
sinusoidal. When you operate in saturation cutoff, then shape will changes because clipping, clamping occurs, na? Clipping occurs, na?
Yes, sir.
That will be different. Then that will become non-linear systems.
Okay, sir.
Okay.
Okay, sir.
Next, Chandrababu. Cheruku Chandrababu.
Hello,
Tell me.
sir. In last phase, 12 left, sir. 12 left.
12F.
Yes.
Tell me.
How the stable, sir? The 1 by S
Pole
plus 2.
leftmost. Here, what is the pole location? Tell. Here pole location -2, na?
-2.
Here pole location.
-3.
As pole moves toward the leftmost side, the system is more relative stable because less oscillations will be there, and it reaches steady state very quickly. It maintains the stable output.
If you go to the imaginary axis, then it will
oscillator.
be okay. Less stable, sir.
Less stable. Right side unstable. Imaginary marginal stable means complete oscillations.
Okay.
Okay, na?
Okay, sir. Clear.
Okay. Abdul.
Sir, this back page number 10, sir.
Tell me, man.
Page number.
Tell.
Sir, here if in closed loop control systems, if it is not automatic, what is the change? Like if we take only iron box, for example, only in iron box you are told, if it is if it not satisfied that case, that all like sensors, if it is not having any sensors, in this case,
If
how
not
it will
having
be-
sensor, then it will become open loop only. Whenever you are not
we are-
measuring output, then automatically it will become an open loop only.
Okay, relay means we are taking like a maximum or
Magnetic
minimum.
switch,
Like,
magnetic switch, na electromagnetic
Ah.
switch. That switch
Okay.
operation, normally closed, normally open switches will be there, na? That only controller.
Okay.
Okay, na?
Page number 12. Page number 12.
Okay.
సార్
Hmm.
ఇక్కడ మీరు ఇక్కడ మోర్ రిలేటివ్ స్టేబుల్ అన్నారు, ఇక్కడ
అవును.
లెస్ రిలేటివ్ స్టేబుల్.
What is the pole location ఇక్కడ? What is the pole location? -1 here.
మైనస్ పైన -1 కింద అంటే
ఓపెన్ లూప్ -2 ఫిక్స్డ్.
ఆ,
ఇక్కడ క్లోజ్ లూప్ -3 మీన్స్ మోర్ లెఫ్ట్ మోస్ట్.
ఓకే
Compared to -2, left most na more stable. But ఇక్కడ ఓపెన్ లూప్ -2, క్లోజ్ లూప్ -1 ఇక్కడ. Here
Okay.
-1 na?
-1 అంటే తగ్గింది.
-1 means less relative stable na?
ఆ,
Yes or no?
అంటే మన ఎస్ సార్, అంటే ఇప్పుడు ఫీడ్బ్యాక్ సిస్టమ్ లేకపోయినా రిలేటివ్లీ స్టేబుల్ ఉంటుందా సార్?
అంతే. If GH is greater than 0, then only more stable. But less than 0, feedback also affect the stability. That's why feedback
Okay.
not always improves the stability. The feedback may improve or harmful to the stability. It may be improved or it may be affect the stability. Feedback always
ఇప్పుడు
not improve.
సార్ ఇప్పుడు GS రెండు అంటే GS అంటే ఒక సిగ్నల్ కంట్రోలర్ అంటే
Process
HF అంటే
main system.
ఫీడ్బ్యాక్.
HFS
Ah.
feedback.
ఇప్పుడు HFS ఫీడ్బ్యాక్, ఇప్పుడు ఫీడ్బ్యాక్ లేదు, GFS ఉట్టి సిగ్నల్ ఉంది.
Then
అది అప్పుడు
pole
closed
location
loop
not changed, fixed position -2. That's all, just stable we'll say.
ఓకే.
We don't talk
అంటే,
about relative
utti
stability
stable-
because
అంటే-
relative stability a comparison na.
ఓకే సార్, ఇది నాకు అర్థం కాలేదు. స్టడీ స్టేట్ ఎర్రర్స్ ఆర్ వ్యాలిడ్ ఫర్ యూనిట్ ఫీడ్బ్యాక్ సిస్టమ్ సార్, అర్థం కాలేదు.
Error when you can generate? What is the error signal? Error equal to what? Input minus output.
ఇన్పుట్ మైనస్ అవుట్పుట్.
Correct or not? So here I want error. Input R, output to C. When you will get R minus C? When there is unity,
is
na?
having no
This is
signal.
C, na?
యూనిటీ.
When it is
Ah,
unity, then only R minus C will come. Then only error will generate. If unity not there, how can you generate error? If unity not there, you will get
Okay.
R minus CH.
సిహెచ్.
This is H, na? Feedback network is H. That means E will become E equal to R minus CH. It is not error. Error is R minus C only. Got it, na?
ఎస్ సార్.
Okay, ma.
ఓకే.
Next, Naveen.
Sir, in page number 10, sir.
Tell.
Sir, how this temperature is changing, sir?
Where?
First you told no, sir, room temperature, the box temperature will be, and how it become 99, 101, and again
Here,
decreasing.
on na power given, then what happen? Heat increases na here. Filament
Yes,
is there,
sir.
na? Yes or no?
Yes, sir.
This filament or coil which increase the heat, na? Because it is on position.
Yes, sir.
What is the doubt?
And again, how it is decreasing like that.
Because here error negative off.
Okay.
Error is just like controller is like this will be there. Like this two plates. In between one controller, one thin plate will be there. So, if error is in case positive, what happen? The polarity across this plate become positive or negative.
Right.
This connector, for example, given negative polarity, negative repelled and touches the one plate. If touches one plate, then it is this plate touches, then it will become on.
On.
In case error is negative, what happen? The polarity across this plate is negative, here positive.
Hmm.
Then negative, this fixed. Connector polarity fixed negative. Here negative, negative, refilled. Then touches other plate. Once touch the other plate, it will become off.
Off.
That means controller is going to become on and off, na?
Yes, sir.
If on, temperature increase. Off, temperature decrease.
Decrease.
Got it, na?
Okay. Okay, sir. Got it.
Okay. Next. Surya Lakshmi.
Yes, sir, it is solved.
Okay, ma.
Sir.
Tell. Tell.
Sir,
Tell.
when you are going on highway, you are seeing that when your speed limit is more than 80. How it works, sir?
More than 80, less than 80, depends on the what? Road condition and traffic.
No, sir, I am not saying that based on traffic.
Ah.
Speed limit, your speed limit is more than.
Oh, when I told speed limit?
No,
When you
are
are
not
driving a bike, I told one example. Why man is closed loop means I told one example.
Okay. Yes.
Okay.
Okay, sir.
Sanjeev. Sanjeev.
Hello, sir.
Tell me.
So I wanted clarity about the last point you said. In the unity feedback system, the steady state errors are valid only for unity feedback system.
Yes,
What
if
does that mean?
non-unity given, you have to convert into unity.
So why is that so, sir?
Error means R minus C, na?
Yes, sir, R minus C.
R minus C, when you will get?
When the feedback is unity.
That's all.
Okay, sir.
Okay. Any more? Any more? Surya Lakshmi. Any doubt?
No, sir.
Okay. Okay. Any doubt? Okay. Today I'll close it here. Tomorrow I'll start the transfer function and remaining thing I'll continue. But today, whatever the basics I told, you revise once. Basically, identification of system is very, very important. Identification of system, that you read it. Okay. Madhura.
Sir, why?
Madhura.
Hello, sir.
Tell me.
Sir, why the errors are called as steady state
Speak loudly, na. Voice is not audible.
Sir, why errors are called as steady state errors?
Error where you see at initial time what happened, the output is oscillates. We cannot find exact error. Steady state errors are more accurate. Steady state means at t tends to infinity. At a larger value of t, output is settled at certain time, certain way, na? Yes or no?
Yes, sir. Yes, sir.
At time increases, what happen? Output will be stable. Output will settle at certain value, so that we can get the exact error.
Okay, sir. Got it. Thank you.
Dynamic errors means you can find with respect to time at anywhere, but that is not in syllabus. Dynamic errors. Okay.
Yes, sir.
Okay. Chandrababu.
Hello,
Tell me.
sir. For completing the control system, how many days are required, sir? When will be completed the?
Daily 3 hours only given, na? And I think weekly 1 day off again.
Okay.
Today 2.5 hours only. Tomorrow 2.5 hours. So, actually, I required around 70 hours, 65 to 70.
Okay. At the end of the month, it will be completed, na?
End of this month, huh?
Oh, yes, sir.
Almost 100% it will complete, no doubt.
Okay, okay. Sir, what is the how to practice the question, sir? Only
Volume
class
1,
itself, sir?
volume 2, volume 1 is there? Control system.
Yes, sir. Yes,
Volume
yes,
1, volume 2, and previous gate questions to practice more than sufficient.
Okay, okay. Thank you, sir.
Okay.
That's it, sir.
Vishnu,
Hello, sir.
tell me.
10 by s minus 2 is stable or not? Unstable now.
Unstable. 10 by s minus 2 unstable.
Yes, right side of imaginary axis.
But open loop system unstable, but with feedback, pole shifted to left.
Okay, sir. First page stability topic is you choose stability option. Why?
Huh?
You choose the question is stability topic. You choose stability.
Where?
Stability topic, sir.
Ah.
I think that time network issue. So.
Tell. What is your
Yes,
doubt?
sir. That's stability pages, sir. After the block diagram and
this one only, na? Closed loop stability.
after that, yes, sir. This 10 by s minus 2 is you select
unstable, but with feedback. Feedback means closed loop system, na?
Yeah.
That's why you have to find a closed loop transfer function. Then we have to decide the stability.
Oh, okay. 10 by s plus 8.
S plus 8.
Okay.
That means closed
This is only stable. Okay, fine.
Okay, na?
Okay, sir. Thank you.
Aishwarya.
Sir,
Tell.
sir, why the best feedback is unity negative feedback, sir?
I told na, negative feedback improves the relative stability, na?
How, sir?
Because pole is shifted leftmost, na?
Pole is shifted.
See here, what is the open loop pole location?
-2.
Closed loop?
-3, no, sir.
-3, na? S plus 3 means -3.
Oh.
Pole shifted to?
Minus. Here you wrote -1, sir. -1 by
That
s
is
plus
when GH is less than 0. This is for GH less than 0.
Okay, sir.
Less than 0 means again unstable, less stable.
Okay.
GH greater than 0, more stable.
Okay.
Okay, na?
Okay, sir.
Okay, ma. Okay, I'll close here.